Hey guys, welcome to final video on a summary on chapter 6, which is energy, work, and power. Okay, there are different forms of energy here. Okay, mainly all these are different forms, and principle of conservation of energy just tells us that we cannot create or destroy energy, but only transform from one form to another. I've got to know this definition; it's important. Um, okay, what about kinetic energy and gravitational potential energy? These are the two main energies that we'll be studying in this chapter for the O and N level syllabus. Okay, you can see that the formula here, both of them have got masses. So the higher the mass, the more kinetic energy or the more gravitational potential energy it has. But for kinetic energy, because of its motion, the main determining factor here will be the velocity or the speed. Okay, so the higher, faster speed will have a higher kinetic energy. But GPE, gravitational potential energy, will be the higher the height, the more gravitational potential energy it has. You can see here all the units here for mass, speeds, height are all in SI units. Just gotta take note of that. Okay, so how do we use the conservation of energy? We can use this formula, energy before equals energy after. So an example here will be if I were to drop a ball from a height of h meters, the energy before it only has gravitational potential energy, right? And energy after it only has kinetic energy. So you can actually equate both of them to each other. And as you can see, mass will always cancel out. Given the g, which is value of 10 meter per second square, you can actually find a h for a particular v or v for a particular h. So explanation, basically total energy before is only GPE because it's not moving, and after it has a KE as it has a height of 0 meters. So the GPE equals mgh, or mg times 0 equals to 0 joules. Okay, basically what this is just equating in a real life scenario. They will actually give you a certain value, so you can actually equate the energy before equals energy after and find the unknowns. That's it. Okay, and final formula here for this chapter will be a work done formula. Work done is mainly force times distance moved in direction of force. Okay, you can see, oh, this done force times distance is very familiar, right? Just touched it in the previous chapter on turning effect of a force. That's moment also equals force times distance. But my force and distance and moment are perpendicular to each other. Whereas here, it's gotta be parallel. Or the distance moved must be in the same direction as the force. Okay, so power is the work done per unit time. This is a definition and this is a formula. So work done, you can actually replace it with a change of energy. Okay, both work done and energy change are measured in joules. Okay, so that's the formula. And okay, hope you enjoyed this summary on work, energy, power. See you guys soon.